Hello everyone, I would like to introduce my topic, Environmental Information Modeling for Building Design, which focuses on the visualization of environmental strategy and parametric filter. EIM tool aims to solve the drawbacks of unintegrated environmental simulation tools while enhancing the communication between project members in the decision-making process. There are three issues below. Firstly, unintegrated EST will cause different simulation formats and overlapping calculations. Secondly, non-translatable simulation results can cause wrong environmental strategies. Thirdly, insufficient information delivery can lower down the design quality. In summary, there are 3 points for EIM: the integration of environmental information in a continuous platform, the filtration of selected parameters based on the project requirement, the visualization of parametric results and strategy. This report focuses on the 4 demonstrations of completed EIM system rather than result in the best design solution. Therefore, the research scope will depend on the following assumptions: building typology, benchmarks, environmental and energy performance parameters, and the environmental strategies and architectural design parameter selection for the graphic category. There are 4 research directions that should be clarified by literature review. Firstly, we define the integrated information program, which should be based on the multi-criteria design space theory rather than multi-objective optimization framework, which only has regular evaluation targets and limited objectives, like lighting, thermal, and energy stability. Secondly, create environmental information filter to evaluate essential parameters by following the project requirements and reference benchmarks. There are 4 points in the figure. Firstly, it shows the target user will be an environmental consultant. Secondly, it includes 2 operation phases, which is manual benchmark collection and technical weighting calculation. Thirdly, you have to input the strategy definition and requirements. And finally, output the customized score and visualize the results. In the end, the EIM development stage has been cleared. Thirdly, visualize the environmental strategies in a practical way, which is easier to understand. The point here is to transfer the parametric result into a graphic category. In summary, there are 3 workflows involved in the EIM development structure. Ensure the case basis and benchmark results through the literature review in the parametric filter development workflow. Clarify the application of customized assessment method by editing the parametric filter into an EST program in EIM tool development workflow. Record the final result, environmental achievement, impacts, priority, and visualization output of each design stage in EIM chart development workflow. This report takes 4 different office layouts in London as experimental objects to complete the EIM demonstration. Therefore, creating a category of benchmarks that's based on the office building typology requirements and London environmental conditions is the prerequisite to confirm the parametric filter basis, which includes environmental design and energy criteria. The category also shows an overview achievement range for each environmental indicator, which is different from each criteria. For example, the target of useful daylight illuminance is 100 to 3000 lux in the 80% area in the BRE report. However, the range is from 300 to 500 lux in the CIPSIS Guide A. Therefore, it is important that the selection of environmental indicators and criteria basis should be properly controlled by the specialist to further meet the project requirement and the client request. In summary, there are 2 characteristics of the parametric filter. One is the accessibility of selected details. It shows the clear priority and proportion of each indicator on the customized scale to define the multi-criteria design space. The other is adaptability and flexibility. As a continuous platform, user can easily adjust the scale by adding new topics or changing priorities according to different needs, building type, and climate conditions. The second phase of entire research is the EIM tool development and programming to upgrade the BPS template and programs. For example, with Ladybug and Honeybee is suitable for EIM establishment. There are 4 stages below. One is the parametric modeling, which aims to input geometry data as controller. The next stage is performance analysis by setting up the selected BPS template. The third stage is to apply the customized weighting system as parametric filter. Finally, the parametric visualization aims to simplify the strategic impact. Once the tool gets prepared, the only work left will be the EIM results analysis and prove the assumption. Again, EIM demonstration aims to confirm the multi-dimensional impacts of environmental indicators from each strategy, rather than focus on the final building performance. Therefore, the EIM outcome analysis should focus on the overall assessment of different environmental strategies in the simplified optimization layers as the figure. In detail, the top issue can confirm case by case through the percentages of each environmental indicator and their potential improvement space. Furthermore, it shows the effectiveness of each environmental strategy, as well as the priority of design solutions. For example, the comparison of the basic achievement score from different layouts shows case 1 in the rectangular open plan gets the highest score of 67.73. Moreover, in case 1, the performance comparison shows the effectiveness of environmental strategies, which includes orientation, rim volume, window and wall ratio, shading type, materiality, and construction layer in the simplified optimization process. It shows not only the strategy impact priority, but also the entire EIM optimization workflow, and it further provides an efficient method to clarify the improved direction. In summary, the actual effectiveness of strategy is evident in the growth rate of environmental indicators respectively. In conclusion, EIM tool shows the advantage of confirming the design information and customize the environmental target in the process while responding to the client's expectation. Instead of traditional EST and BPS operation, the integrated environmental assessment outcome from EIM can be beneficial to clear the design direction at any stage.